All right, guys, more STAT 1800 final exam study guide, problem 16 through 20 will be worked in this video. So let's do it. So according to a recent report, 46% of college student internships are unpaid. Well, that's not good. A recent survey of 60 college interns at a local university found that 27 had unpaid internships. Used the 5-step p-value approach at alpha 0.01 is different than 0.46. So gang, we know that's going to be equal to 0.46, and this is going to be not equal to 0.46. So there's nothing that says it's higher or lower. It just says it's different. What is the test statistic? Well, gang, I'm going to use my stat lab here. So I'm going to write all this down so I don't mess up when I get there. So our claim is 0.46, not equal to. So we have 27 out of 60. And our alpha value is 0.01. All right, so this is going to be pretty easy. So go to stat, go to proportion stat, one sample with summary. So we have 27 out of 60. And we have 0.46 and not equal to 0.46. We want the test statistic, which is under Z-stats, so that's going to, let's see what we got around to. 2 places. So we have negative 0.16. What is the p-value? The p-value is 0.8765. The final conclusion, well guys, our p-value is higher than our alpha, which is 0.01 in this case, so there is not sufficient evidence that the proportion of college interns that had unpaid internships is different from 46 because the p-value is greater than the level of significance. All right, 17. Bank A and Bank B have each developed an improved process for serving customers. The waiting period from the moment a customer enters until he or she reaches the counter needs to be shortened. A random sample of 10 customers is selected from each bank. Assuming the population variances are equal, is there evidence of a difference in mean? So guys, we're looking at a difference. There's no there's no indication it's higher or lower than. Find the F statistic. Okay, am I missing? Oh, yeah, I was missing the data. I say we could even do this. All right, so we are testing. We want the T-stat. So guys, we need to go to T, to sample with data. So we want bank A. Sample 2, we want bank B. Pool variances. Said we had equal variances, right? Is that what? Assuming the population variances are equal, so we use pooled. And we have mu1 minus mu2 equals 0. So guys, we've got all we need. So we want the test statistic negative 3.26. Find the critical value. Okay, this is interesting. So we have 10 from each, so our degrees of freedom will be N1 minus N2, or I'm sorry, N1 plus N2 minus 1. So we're going to have 10 plus 10 equals 20 minus 1. So guys, our degrees of freedom are 19. And again, we are testing at 0.05 level of significance. So we need to go to Stat Calculator T. Again, our degrees of freedom is 19. And we want higher than, and we want 0.025 in the upper tail. So 2.093. Shoot, did you guys see what I did? I messed up. I went N1 minus N1 plus N2 minus 1. It should have been minus 2 degrees of freedom, because you have 1 degree of freedom for each of the sample sizes. So it's essentially N1 minus 1 plus N2 minus 1. So it's N1 plus N2 minus 2. I would tell you it's the first mistake I've ever made, but it's got sloppy there, guys. So 2.10. Sorry about that. What's going on now? 0.05. 3 places. Oh, I rounded incorrectly. It's not my best video. Okay, again, I got caught on a technicality here. I see now it says find the critical value. I assume this is value, so use a comma to separate. So it would be negative 2.101 and 2.101. All right, it is what it is. Okay, again, well, I'm not going to beat a dead horse here. Choose the correct conclusion. Our test statistic is clearly outside the bounds of the critical value, so we're going to reject the null, and we're going to have that there is sufficient evidence that the mean waiting time between the two branches is different. All right. Determine the p-value. So guys, we had that. So let's just go back up here and do the results. So the p-value is 0.0043. Interpret the p-value. It is the probability of attaining a sample that yields a test statistic further away from 0 in the negative direction. And guys, it's actually a two-tail test, so it would be in either direction. In addition to equal variances, what other assumption is necessary? Well, guys, we need both samples. Populations are approximately normal. Construct a 95%. Oh, this is the problem that just goes on and on and on forever. I thought we were done way back here. So let's do so So let's edit this using 95% confidence interval. So we get negative 3.831 and negative 0.829. Now, more than likely I want us to go to 4 places. No, it's just 3 places. So negative 3.831 and negative 0.829. Interpret the confidence interval. So with 95%, the difference falls. So guys, that's exactly what it does. Wow, long question. So if you have samples N1 and N2 in performing a pooled variance t-test, well, this is pretty cool considering I screwed this up earlier. So it's going to be N1 plus N2, 28 minus 2, so it's going to be 26. Number 19, an experiment has a single factor with 7 groups. So we have K is equal to 7. And we have 4 values in each, so N is equal to 7 times 4, which is 28. In determining the among group variation, there are 6 degrees of freedom. In determining the within group variation, there are 21 degrees of freedom. So let's go ahead and do that. 6 degrees of freedom for the among group. The within group has 21 degrees of freedom. Total degrees of freedom are 27. The sum of squares for among is 150. The sum of squares for within is 105. Total sum of squares is add those two together, so it'll be 255. Now the mean square variance, it calculates that for you. So it's going to be 150 divided by 6. So it's already gone ahead and done that for you and given it to you as 5. That's kind of goofy, but oh well. And then within, I'm sorry guys, that should be 25, and this should be 5. And the F statistic, of course, should be equal to 5. Now at 0.01 level of significance, what is the upper tail critical value in the F distribution? So guys, look over here. We have degrees of freedom 6 and 21. And the upper tail probability is 0.01. So gang, we close this down. We go to the STAT calculator and go to the F distribution. So our degrees of freedom again are 6 and 21. And it's always an upper tail probability with the F distribution. So we want this upper tail here to be 0.01. There's no two-tail stuff with the F distribution. It's always greater than. So 3.812. So 2 places, so 3.81. Just double check that. I don't want to get my hand slapped. Since the decision rule for testing the null hypothesis that all 7 groups have equal population means, we're going to reject if the F stat is greater than 3.81. What is your statistical decision? Well, guys, our F stat is 5. Our 5 is bigger than the critical values, so since F stat is greater than the upper tail critical value, we're going to reject H sub O, so there is sufficient evidence to conclude a difference in the population means. All right, gang, final question. The Anova summary table for an experiment with 5 groups. So guys, K is equal to 5. And 7 values in each group. So 7 times 5 gives us 35 total sample size. We'll complete the value to the... Okay, so it's already filled it in for us, actually. So the F-stat again is 5. So so we're going to have we have 5 groups, so we need mu1 through mu5. So that would be our null hypothesis. The F-stat is 5.00. We get that from our table. Determine the critical value. So again, we have degrees of freedom 4 and 30 in the upper tail with a 0.05 level of significance, which is given right here where I'm circling. So, so degrees of freedom again are 4, 30. The upper tail probability is 0.05. So again, we put all of the level of significance in the upper tail. So 2.69. So our F statistic, so we're going to reject the null and say that there is sufficient evidence that the difference in the population means of the groups. All right, guys, that's it, right? Good deal.